Good morning. Today our topic is 21.1 Ideal Operational Amplifier. Right, let's just review. For ideal operational amplifier, we have a starting point, sensing device, and the next stage is processing unit, and then the output device. The change in physical property, our sensing, right? Outside that, temperature change, sensed by the sensing device. And then after that, it must be processed by this processing unit, and then display our output. Last lesson, look at sensing unit, sensing device. Look at thermistor. You look at light dependent resistor. Look at strain gauge. So let us carry on this trip. We're going to processing unit. Right? So basically, the processing unit is just some form of electrical circuit that is connected to the sensing device and also the output device. So basically, this one provide sensing device, we see provide a voltage variation to the processing unit. Processing unit process it and give a voltage variation. And then this output device will show what happened. Right? Sometimes if the voltage is too small, then we have to amplify it before we send it to the output device. Right? So we use block diagram. Easier to summarize what we want. Right? Sensing device, the first stage, the processing unit, and the output device. So we say that this is an electronic sensor to monitor whether the temperature in a refrigerator is above or below a particular value. So we have this one. Previously, we look at, right? In this case, example, there's your sensing device, the thermistor. It sends a change in temperature in the refrigerator. This one sends, these two are potential divider. It keep a potential, constant potential across here. So basically, as the temperature change, the sensing device, there will be a potential, a resistance change here. So we are not to take the potential across here, but across here. That means if it's hot, this sensing device will give a low resistance. Potential here will be low, potential here will be high. So we want the variation type. High temperature, high potential difference. The variation of potential difference must corresponding to the environment temperature. So now we are going to look at there's a sensing device. Now we are going to look at processing unit. In this case, this is a comparator. Right? There's a two voltage input. This one V minus and V plus. Compare these two and give an output. This is the power supply. Then after that, we will look at this one, the output device. Okay. Well, an amplifier is just any device that changes, usually increase the amplitude of the signal. The relationship of the output to the input of the amplifier is termed the gain. So basically, we want to change the amplitude, we want to make the amplitude bigger, not the frequency. That's why we use the term amplify, not magnify. So like in this case, for amplifier, we are interested in the gain. How much has the amplitude increased? Voltage gain of an amplifier is the ratio of input output voltage, what comes out compared to what goes in. So basically, the gain of the amplifier, purpose of amplifier to increase the amplitude. but the frequency remains constant. That's the reason why we don't use the word magnify. Right? Or in mathematical form, V out over in, V in. V out is here, V in is here. And remembering that, right? Our speech can be something like that. And we can analyze it and find that it can be made up of different amplitude and frequency of sinusoidal waveform. So an amplifier will require to amplify all these by the same amount. When where the signal contains several different frequencies, like in this case there, the amplifier should increase all the frequencies by the same proportion. That means if you double, all these amplitude must be double. And then we call such an amplifier linear. Right? Unfortunately, that is not so with some amplifier. Right? There's an input signal, and sometimes you get this output signal distorted, different from the input. So one of the problems with amplifier in analog system is that to some extent they fail to do this, and they may change the wave shape of the signal. So there's an input signal. When you want to amplify, you want to have exactly the same coming out, but larger amplitude, larger voltage, right? Larger maximum voltage. Not like here, it's cut off. So the output signal is completely different from the input signal. Right? So we say in this case, if it doesn't amplify all the different frequency with the same amount, we say it's non-linear. And in effect, like, purpose of amplifier is to amplify what I speak and faithfully reproduce that to the listener. So in this case, it will change if it's not linear, it will change the tone of the sound. And in this case, we say it's distorted, right? Different from the input. Okay, that is your discrete component. That's your IC. Okay, so let us just stop for a while and view a video on integrated circuit, give you some brief idea. Okay, integrated circuit.
Integrated circuit. The integrated circuit was independently designed by Jack Kilby at Texas Instruments in late 1958 and by Robert Noyes at Fairchild Camera and Instrument in early 1959. An integrated circuit is a collection of interconnected transistors, diodes, resistors, and capacitors fabricated on a single piece of silicon known as chip. What is a chip? A chip is a part of a single crystal of silicon which is cut into thin slices approximately 0.05 centimeters in thickness. The slice of silicon crystal is called a wafer. Integrated circuits are used in a variety of devices like microprocessors, audio and video equipment. Due to their small size, integrated circuits are used in almost every type of electronic equipments. Integrated circuits are categorized as monolithic ICs and hybrid ICs. The monolithic IC is a microcircuit consisting of elements formed on the surface of a common substrate. The word monolithic is derived from the Greek word mono meaning single and litho meaning stone. Thus, a monolithic IC is built into a single stone or a single crystal. The hybrid IC is a microcircuit consisting of passive elements formed on a common dielectric substrate. Most digital circuits use monolithic ICs. Hybrid ICs are used in microwave ovens and in speed blenders.
Okay, let's go back to our okay. That's your discrete component, resistor, that's your IC. Right? Usually it's a different form. This is for your info, that's all. Yeah, it's basically integrated circuit is an electronic circuit or chip of silicon about 5 millimeters square, very small, consisting in some cases of hundreds of thousands of transistors and perhaps diodes, resistors, and capacitors, along with interconnection. Integrated circuit are building blocks of microelectronic. Okay, so rather than have discrete component, have all the wires there connecting the transistors, the diodes, the capacitors, we build everything together in this IC, that integrated circuit, so that we don't have to worry, we just buy the whole thing. Right? So this is the operation amplifier that we will be interested in. So we can build this up of each individual component like resistors and transistor. Okay, or then that will take a lot of space. So we build it up in a integrated circuit. It is smaller. You don't need to know about all this. You don't need to know about the circuit. You just need to know how it's just for your info, that's all. Operation amplifier uses analog where do we use it? Analog computer, low power amplifier. So basically, operation amplifier is an integrated circuit, a complex circuit containing about 20 transistors together with resistors and capacitors, all formed on a small slice of silicon. The slice is sealed in a package from which the emerging connection to the external circuit there. So it's the engineer who design it. Depend on what they want it, they design for purpose. Then the characteristic will usually be found in the handbook. There are so many IC that nobody can remember it. Only if you want to look for a particular one, like 741 operation amplifier, the characteristic, then you go to the handbook. Engineer would have determined for you the handbook, how is the output and input, how does the output changes with the input. Right? That's how it looks like. And that's how we can see the circuit inside there. Representation only. This is a simple operation amplifier. There's a pin that we have to connect. Right? This is for your information. You don't need to know so much about that. The one we are interested in is 741. Okay, so you can see that this is the integrated circuit. These are all the connection there. Conductor. Okay. Find all these integrated circuit in the microprocessor, studio equipment, calculators, watches, and electronic game, even in your smartphone there. So that's a symbol for operation amplifier. And as an amplifier, it's an active component. What does it mean? Means that it not like a resistor or capacitor, right? Where it doesn't need a power supply. This one need a power input. This is a power input. This is a supply, positive supply. This is a negative supply. It's a power supply. Power supply is used to increase the amplitude. Means if your Vs is 10 volt, then your amplitude that come out can only be 10 volt. Cannot be more than that. Okay, let's go to understand some of the AS thing, AS physics that you have learned. There's your source of EMF, right? The source has a internal resistance. R is internal resistance. R is the load. E is the EMF of the cell, is constant. For the output voltage to be large, this one, the out to be large, means you want all the EMF to fall on the output, then R must be small. Or alternative is to make this capital R, the load, as large as possible. If we make it infinite, so much better. Infinite, all the EMF will be across V out. We don't have to worry about this one. Right? So the input source have an input internal resistance, and then it is connected to a load. This is usually the source, and then we connect it to the input of the operation amplifier. So that's the reason why the input of the operation amplifier, we want this one to be infinite. That means very, very large. So that all the EMF of the source will appear on this V out on the input of the operation amplifier. And on the other hand, this voltage can be the output of the operation amplifier. Remember, the output has a resistance, output impedance or resistance, and then you usually connect it to a load. So in this case, it's the other way around. The output resistance, we want this one to be 0, so that your V out is equals to the EMF of the source or the output of the operation amplifier. That means the output on the load is straight away the output from the operation amplifier if the output resistance is 0. Okay, so that's a symbol of an operation amplifier. There's a positive power supply, there's a negative power supply. The reason why we have positive and negative is allow you to amplify the positive part and also allow you to amplify the negative part. And then this is the output. The negative terminal is called the inverting input, right? Because what you put in positive will come out as negative. That's what it means by inverting. This is a non-inverting input. That means when you put in positive, it comes out positive. Does not change the input. So the output equals to A naught. Basically, the input is just your V plus minus your V minus. That's the input. This amplifier take the difference between these two and then amplify it. Right? A naught is the gain of the amplifier. It's determined by the engineer who designed it. You cannot change it. Right? So there's the input voltage. The difference between the positive and negative terminal. And remembering that, we will always have connected the input to a source, and then that source will have internal resistance, and the output is connected to a load. Right? Usually we use equivalent circuit. It's easier for us to imagine rather than just to see a triangle, it doesn't help us. Right? but we do not stretch it too far. Right? Just imagine that it represents, for the op-amp, there's an input resistance. Don't try to imagine how it connected. Not that to do with the circuit. You just know that it has an input, equivalent circuit. It's a theoretical circuit, which is simpler than the circuit it represents. But we have the same input and output as well. That's the only reason. Help us to picture how it works. That's all. Right? You cannot go and say, oh, how is this two not joined, and then how can this have a voltage? No, cannot read too far. Right? Let's look at the terms there. The input voltage is your V plus, this one, minus your V minus. Then that is your input impedance. Right? We don't call, you can think of it as resistance if you like, but usually we call impedance because it doesn't have just a resistance. It can be a capacitance, it can be an inductor there. That's all we call impedance. Right? That means if you like the resistance that includes the capacitance and inductance and also the resistance. And it has a output resistance, output impedance. And then you can imagine this is a voltage source. Right? That voltage source depends on what you put in, the difference that you put in, times the gain of the amplifier. And this part is the output. That is usually the earth line. A now is called the open loop gain of the operation amplifier. That means it's the gain of the amplifier itself. Right? It's just fixed by the engineer. We cannot change it. Right? So that's the output voltage. So if that is 0, then your output voltage equals to that one straight away. Right? And source that. Right? Basically, the difference between the two terminal, positive and the negative, and then you just amplify it. Okay. So that ideal is what engineer wants, what they design the amplifier for. So as we can see, if their input impedance is infinite means very, very large, then whatever you put in, you won't bother about the impedance or the internal resistance of the source. Whatever you put in will come out to the input of the op-amp. That's the reason why we want infinite input impedance. Then 0 output impedance. Same reasoning, right? There's always a load that's going to come out. So if this is 0, then this output voltage, right, the source voltage becomes the output voltage. Output impedance 0. Infinite bandwidth. Right? What does bandwidth means? It's just a range of frequency over which the gain is constant. That's your bandwidth. All the different frequencies that I fit in, or the range of frequency that the gain is constant. We don't want frequency where the gain of the amplifier change. We want all the frequency, range of frequency where the gain of the amplifier is still the same. That's the bandwidth. We want infinite. That means any frequency you put in, you will have the same gain. That is what we want. Right? Remember, our speech can have different frequency and different amplitude. And we want to amplify all these different frequency with the same gain, with the same amount. Then we want infinite open loop gain. That means we want the gain as large as possible. So that even if we have a small value coming in, it will amplify very large for us. Okay? So infinite open loop gain. Infinite slew rate. Remember, inside there is a lot of different sub circuit. So the current or the electron has to flow from one end to the other. So we want infinite slew rate. We want that whatever change here, straight away will come out. It doesn't have any delay. no time delay between the input and the output. That's why we want infinite slew rate. Because this is for your information. Right? Infinite input impedance. That means no current will enter or leave the input. But usually for real one, what does infinite mean? It means about 10 to the power 6 to 10 to the power 12. That's good enough. Right? And usually the current that enters is very small, micro ampere or smaller. Infinite open loop gain, right, is about 10 to the power 5 for DC signal. There's no such thing as infinite, no such thing as infinity. Right? It's just in our head only. Zero output impedance, right? Usually it's about 100 for real one. We want it as low as possible because it has to be connected to a load. Infinite bandwidth means all the frequency will be amplified by the same amount. But we find that is not possible. Bandwidth not infinite, limited. Infinite slew rate, we find also that is not possible. Right? The slew rate is about 10 volt per microsecond. That means the larger your voltage, the greater will be your delay, the time delay. Okay, so let's summarize bandwidth as a term that you need to know for this topic. Range of frequency over which the gain is constant. Memorize. And the other term is saturation. What is it? Occur when the output voltage, this is the input voltage, there's output voltage, right? There's a power supply, Vs minus Vs. So the output voltage, like this case, cannot exceed Vs because that's what you give. So because that's what you give, it will cut off. That's called saturation. Output voltage stay at Vs for further increase in input voltage. That means at a certain point there, at this point there, the input can still increase, but the voltage doesn't change anymore. Same here. Right? The input can still increase, but the voltage output stays at your power supply voltage. And we will find out later on, very small difference between the inverting and non-inverting input will produce saturation. Or another way to state what is saturation is to say that it's a flattening. That's what it means, flattening. Or you cut it off, clipping effect. We stop the output voltage from reaching its amplified value. That's the amplified value. Dotted line. Dotted line is the amplified value. You cut it off. That's what saturation is all about. Okay. And in this case, that's what it means by clipping. When the output voltage exceeds the supply, the output voltage stays at the supply voltage, no amplification like here. Then it just cut it off. It's not amplified. This part of it may be amplified, but the part is cut off. So it means that the waveform is completely different from what you put in. Okay, that's your off amp. Right? How do we put voltage on it? Right? We have a V plus, we have a V minus supply. How do we do that? That's called biasing the off amp. We have to bias it. We have to put voltage there, supply voltage there, and so that it can work. So we have usually a zero line, the earth line, and then we have power supply, can be battery in series, Vs, and then we can have battery power supply, another set of battery. Yeah, that will give you your minus Vs. This will give you your plus Vs. So we call this a dual or split power supply. Then we just join it up. Right? Remember, this is not a joint. It's just the two cross each wire. Right? No touch. Just touching, but no current will flow through each of them. They are insulated wire. So that is a positive line. Supply to the pos. This one will be your positive supply. That one will be your negative supply. And then we can put an input voltage there if you want. Vs, join to a battery if you like. And then put an output voltage, the same thing, we join to another battery with different EMF. And then output, we can use a voltmeter to read out what's the difference between the two values. So the power supply, this one, is usually 5 to 15. Right? That's why we have low power amplifier. It's not a high power amplifier, low amplifier. It's quite safe for us to use. So that's another representation. Passing it. Okay, so you might have two different power supply, guide you or split power supply. Such a supply can be thought to be made up of two sets of battery, two different sets of battery if you like. And then the common link is the zero line, right, or the earth line. Earth line is your reference line for your input and output voltages. They are measured from this earth line. So we have a positive supply, we have a negative supply. Right? So it allows us to amplify the positive input, and you also allow to amplify the negative input. If we don't have the negative, if we earth this one, then whatever output is always zero. We cannot amplify the negative input. Right? Let's try an example. Help us understand what's happening. There's a gain of the amplifier. There's a supply to the op-amp, and you are asked to calculate the output. Right? The V plus and V minus is given you. So we just use a formula. V out is A naught, V plus minus V minus. We take the difference between these two values and then multiply by your gain. Then we get 200 volt. But we say impossible because we only provide 15 volt. So how are we going to get a 200 volt? So it means that the op-amp will just indicate to you 15 volt. We call this saturation. Cannot give you 200 volt because whatever you give only come out as the maximum. 15 volt is the power supply. Let's look at the voltage where it's smaller. Right? About microvolt range, same thing. Take the difference between the positive and negative terminal. And then we remember this one, negative must be there. Right? It tells you that then the negative terminal is greater. This voltage is greater than this voltage. So the output will be minus 3 volt. It can amplify. Right? But these are in microvolt range. This is millivolt range. So usually we don't work with so small. So the op-amp in this case can amplify only very small voltage difference, which is not good. We hardly use this one. As we repeat, very small difference in voltage can be amplified, but we usually don't use this small voltages different. Amplifier is saturated for small difference in input voltage. And polarity of the output depends on the difference between the two input. If your V minus, negative input voltage is greater than the V plus terminal, then the output becomes negative Vs. Right? We call this comparator. That means it compares the two input and gives the output depending on whether the input is greater. Which input is greater? If the non-inverting is a positive terminal. This positive terminal is non-inverting. Is greater. That is amplified. So you straight away will give you Vs. And remember, amplified by the output cannot exceed the supply voltage. Okay, so it cannot exceed the supply voltage, you stay at supply voltage, that's why we call saturate. So there's a comparator. To summarize, if that terminal, the V plus terminal is greater than that one there, then straight away you become positive. Whereas if the negative voltage there, that terminal there, is greater than this one, straight away you will get minus Vs. Both of them are the same value, then the output will be 0. That's a comparator. Okay? You compare and give you output. Which terminal is greater? That's all. And then we can study the characteristic of the operation amplifier. Right? That means tell us how it behaves. Right? You should be able to recognize this is your V out axis, this is your V in axis, the difference between these two terminals. Okay. So we can see that right, it stay at for higher voltages, higher difference in voltages between the input, it stay at 10 volt. So we can represent that as the op amp 10 volt minus 10 volt, minus 10 volt here. Only this part is amplified. So you should be able to read the characteristic and tell you, here is 10 volt, minus 10 volt, there's a power supply. The gain, we can take the slope here, right? From here, this is your Y, this is your X, right? That is your X, that's your gradient. Right? Only for this part, we can determine the gain, where it's linear. So it's, we can take it as slope at 10 divided by this one, right? 100 times micro, then it changes to volt, is 10 to the power minus 6. Weakness of amp without negative feedback. The gain of the amplifier depends on the internal component. Internal component decided by the engineer when they build it, and the gain is also determined by the internal component inside there. But as the component age with time, the gain is likely to change. The high gain would mean that it is not suitable for amplifying certain oscillating voltage. Right? As we can see, as soon as the difference exceeds a few microvolt, then it cannot amplify anymore. It becomes saturated. So it's not good because what we deal is usually millivolt difference. Well, let's go to worksheet and try some of the question. Okay, so let us look at comparator. This is a comparator. Right? The supply is 10 volt, minus 10 volt. This one, the negative terminal, is a positive terminal. So the negative terminal has a greater voltage than the positive terminal. So the output will go straight away to 10. Right? In this case, look at the positive terminal. The voltage is 2.5. Negative terminal is 2.4. So straight away, you go to 15 volt. That's what it means comparator. Right? Let's apply it a bit further. If your input is just like you switch on, current flowing, and you switch it off. Right? Voltage input is 1 volt. Okay, so this is your input. What does the output look like? Right? When it's 0, everything is 0. Right? This is connected to 0. So it's 0, everything is 0. But when this is 1 volt there, this terminal is greater than this one. So it becomes minus 10 volt. So straight away, it's minus 10 volt there. So we can think of it as output voltage is out of phase. 180 degrees out of phase. Right? Or inverter. This operation amplifier act as an inverter. It invert whatever you put in, it invert it. Or 180 degrees out of phase. Right? We can go a bit further. If we use a sinusoidal input here, sinusoidal input, Your root mean square value is 1 over root 2. Your frequency is 50 Hertz. Right? Remember, we are working with ideal of M, so we don't have to worry about all the inside there. What is the peak input voltage? So you should be able to calculate. Right? That's from your AC that we have studied. Your V root mean square is V naught divided by root 2. So your V naught is V root mean square times root 2. That's your V root mean square. You get 1 volt. And to sketch the sinusoidal input, we must find the period first. Okay? So from frequency 50 Hertz, we get our period. Change it to times 1,000, we get millisecond. Okay? So that's what we get. Peak value 1 volt and 20 millisecond. Okay? So that's our input. Then understand our op amp. You want what is the next thing that we want? Sinusoidal input and see the same graph, the output waveform. We want the output waveform. And then see this one. The input, the negative input is connected to earth. So it means that this one, it doesn't invert. It just amplify only. So it means that as soon as the positive terminal or the non-inverting terminal is greater than 0, the output will just be 10 volt there. Yeah, it doesn't amplify. Okay, so that's the input. That's your output there. Right? A distorted form. So that's the output waveform. Distorted. Not good. Right? Not useful purposes. Completely different from the original input there. So of course, the next topic we are interested is how to make sure it can amplify. So output is distorted. Okay, so you can go to my Facebook to download the notes, the PowerPoint, the video, or you want past year paper to try out the question, can go to Facebook also, past year paper A2, past year paper A2, sorry about that, on there, past year A2, can find the past year paper from 2001 to 2010, topic by topic, for you to practice. Try out the question before you go for the exam. But sometimes they do repeat, or if you don't have Facebook account, you can go to YouTube. Right? You can find it, search under my name, and you will find under 21.1 ideal of M. So that's the topic for today. The next topic will be negative feedback. Okay, so we end our lesson for today.